Hello everyone, it's a pleasure meeting you all in my mathematics class. Today let me explain a problem in functions of several variables. A function is said to be a function of several variables if the dependent function depends on two or more independent variables. What I mean is, say for example, you see that if I write A is a function of L and B. A means here the area of the rectangle, The area of a rectangle depends on the length and breadth. And if length varies, area varies. And breadth varies also, the area will vary. Therefore, you see that this is a function of two variables. So, a function is said to be a function of two variables if the number of variables, if the a dependent variable, it depends on more than one independent variables. Okay, here L and B are independent variables, and area depends on the two independent variables. Therefore, this is a function of several variables. So, whenever, see here I have written here in this problem, you are given a function phi which is a function of u and v, which is a function of several variables, more than one. And is written in terms of the variables. Now you see that this u is in turn given in terms of u is equal to e to the power of x into cos y, and v is equal to e to the power of x into sin y. We have to prove this particular result here. This one is dou square phi by dou x square plus dou square second derivative of phi with respect to x, second derivative of phi with respect to y is equal to u square plus v square into second derivative of phi with respect to u and second derivative of phi with respect to v. This is what we have to prove. And this is a function of several variables because phi is a function, this phi is a function depending on two variables u and v, and u and v in turn, they depend on two other variables, independent variables, namely x and y. This is what it is. And u is a function of xy and v is a function of xy here. V is also a function of xy. Now, so what we have to prove here is, so here in this case, take the first derivative of phi with respect to x, then you take the second derivative of phi with respect to x, and then find out what is the result. Then likewise you find what is d of dou phi by dou y, and the second derivative dou square phi by dou x y square, and I have named it as 1. This 1 is nothing but your dou phi. See, first I find dou phi by dou x, then after then I find dou square phi by dou second derivative of phi with respect to x, I call it as 1. Then I find dou phi by dou y, the first derivative of phi with respect to y, and then the second derivative of phi with respect to y, I call it as 2. And then I add 1 and 2 to get this result. This is what I am going to do. Okay. Now let me explain the step by step. What is this dou phi? Before that, you see that I have given you here dou phi by dou x. Since phi is a function of two variables, dou phi by dou x is equal to dou phi by dou u into dou u by dou x plus dou phi by dou v into dou v by dou x, because this phi is a function of u and v, and u and v are again functions of x and y. So if you are going to find dou phi by dou x, then you see that this must be dou phi by dou I dou u into dou u by dou x, and likewise dou phi plus because v is also a function of x, dou phi by dou v into dou v by dou x. So this is the first and foremost step about the functions of the derivatives of the function, which is a function of several variables. This is how it should be done. Okay. Now after then what I do is, I have written this in the place of this dou u by, I know the value of dou u by dou x. See, ux means dou u by dou x. Its value is e to the power of x cos y. And what is e to the power of y? Because you see that u is equal to e to the power of x cos y. If you take the derivative of u with respect to y, e to the power of x is treated as a constant, and derivative of cos y is minus sin y. That is why we get this result. Coming to Vx, what is this V? E to the power of x sine y. You take the derivative of V with respect to x, then e to the power of x, you have to differentiate e to the power of x. Leave sine y as a constant. Give it, don't do anything. So this is e to the power of x. If you differentiate with respect to x, it remains the same. So e to the power of x into sine y. When you differentiate this with respect to y, e to the power of x is treated as a constant. Find the derivative of y, sine y. The derivative of sine y is cos y. So I have kept ready these results to incorporate here. So this simple things you must know. Okay. Then dou phi by dou x, as I told you, dou phi by dou x is given like this, and in the place of dou u by dou x, I write its equivalent. What is dou u by dou x? E to the power of x into cos y. Here I have deliberately used this phi u. This phi is nothing but dou phi by dou u. That's all. Phi u is dou phi by dou u. In another way of writing, dou phi by dou u is phi u. Nothing more than that. Okay. Now that is e to the power of x into cos y into phi u plus e to the power of x into sin y into phi v. What is this e to the power of x sin v? This is dou v by dou x. So in the place of dou v by dou x, I write this, and this phi v is nothing but what? Dou phi by dou v. So this is what I have. So this is my first step. Then here I can write this as, see, this is nothing but what? This is nothing but your u. This is nothing but your u. And this is nothing but your v. This is your v. So I can write this as u into phi u is dou phi by dou u plus v into dou phi by dou v. So you can very well understand that dou by dou x of phi. So you can very well write this as dou by dou x is nothing but u d by du plus v dv by dv. So in the place if you put phi, because phi is a function of u and v, phi you throw to this phi. So this is what I have finally got the result. So dou phi by dou x is equal to u dou by dou u plus v dou v by dou v. This is a very, very important result. This, after all, this phi is coming through and phi is a function of u and v. That you must understand that. Then I go for the second derivative of this with respect to x again. That is dou square phi by dou x square. But dou square phi by x square is nothing but what? Dou by dou x of dou phi by dou x. What is that? Dou by dou x of dou phi by dou x. That is dou square. Here it is dou square. It is see dou square. Dou square phi by dou x square. That is in the place of this dou. See dou by dou x. What is dou by dou x? As I have written here, dou by dou x is equal to u into dou by dou u plus v into dou by dou v. That is what I have written here. So in the place of dou by dou, in the place of dou by dou x, I can write this. And in the place of dou by dou x again, I can write the very same again. That is u into dou by dou u plus v into dou by dou v. It is u into dou by dou u plus v into dou by dou v. Here it is. Dou by dou v. And u into dou by dou u plus v into dou by dou v of the function phi. That is nothing but what? Now if you go for the multiplication, you just go for the ordinary multiplication here. U into u is u square into dou square by dou u square. This phi after all it is coming through. Don't worry about that, it is coming. So u into dou square by dou u square plus v squared into dou square by dou v square plus 2ub into dou square divided by dou u dou v. It is dou u dou v. And this, after all, this phi is coming because phi we are differentiating this phi with respect to x and y. Therefore, we get this result. So I can very well write this as u squared into dou squared by dou square phi by dou u square plus v square into dou square phi by dou v square plus 2, you see, this is u into v dou by dou u into dou by dou v. That is dou square by dou u dou v. If you multiply these two, you will get this, see. If you multiply these two, u into v into, see, dou square by dou u dou v of phi. This is phi is here. So when you do this multiplication, u dou by dou u, v dou by dou v, then you get it as u into v dou squared by dou u. That means derivative of phi with respect to u and then with respect to v, or vice versa, no problem. So we get this particular result. So what is that we get here? Dou squared phi by dou x squared is equal to u squared into dou squared phi dou u squared plus v squared into dou squared phi by dou v squared plus 2uv dou squared divided by dou u dou v. This is my first one. So I have got what is my dou squared phi by dou x squared. Similarly, we will do exactly in the same lines you have to do. Only the changes you have to find what small changes will be. That is dou phi by dou u. What is dou phi by dou u? Dou phi by dou u into dou u by dou, because you are differentiating with respect to, partially differentiating with respect to y. Therefore, dou phi by dou u into dou phi by dou y. In the same way, same as this, but in the place of y or x, you are replacing it by y. So, dou phi by dou u, dou y is equal to dou phi by dou u into dou u by dou y plus dou phi by dou v into dou v by dou y. But what is the value of this? Using this 1. What is the value of this? Dou u by dou y. See, dou u by dou y is minus e to the power of x sin y. Say I have written here. And what is the value of this? Dou v by dou y. Dou v by dou y. What is dou v by? Here dou v by dou y is e to the power of x cos y. So I have written here. Again, the meaning of this is, as I told you, the meaning of this is dou phi by dou u. What is the meaning of this? Dou phi by dou u. So what is that you get here now? But what is this minus e to the power of x sin y? What is your e to the power of x sin y? E to the power of x sin y is your v. Therefore, I write it as minus v into phi x plus, what is the value of this e to the power of x cos y? It is given that u is equal to e to the power of x cos y. So I write it as u phi v. That means the value of this, the derivative dou phi by dou y is equal to minus v into dou phi by dou x plus u into dou phi by dou v. You call it as using 1. So you call this as, now, so we have got this, using 1 we are able to get this result. So I have got my dou phi by dou u. Now let me find second derivative of phi with respect to y. That is dou squared phi by dou y squared is equal to dou by dou y of dou phi by dou y. That is, now you see that this is nothing but what? Dou by dou y into dou by dou y of phi. But what is your dou by this thing? See, here it is dou by dou y. See, dou by dou y is equal to, it is what we have got here is that u, see, u dou by dou v minus v dou by dou v. See, this is what I mean. See, just check this. This is nothing but u into dou phi by dou v. See, u into dou by dou v. Because whatever be the function phi, you can put it here. So it is phi we are differentiating, that is dou by dou y is equal to dou by dou y is equal to, see, u into dou by dou v minus v into dou by dou u. So you can, in this place, dou by dou y, you can write it as what? U into dou by dou v minus v into dou by dou u. So I replace this dou by dou u or dou y by this value, namely dou by dou y is equal to u into dou by dou v minus v into dou by dou u. Now I put it like this, my substitute here and also here, and it is operated on the function phi. Now you go for the ordinary multiplication, you see that u squared into dou squared by dou v squared. Minus into minus will make it as plus v squared into dou squared by dou u squared. Then u into, see, u into v, that is minus uv dou squared by, see, when you multiply this and this, when you multiply this and this and this, you will get it as minus uv dou squared phi by dou u dou v. And similarly, when you multiply this and this, you will get again minus of this. That is why I have written it as minus 2 times of uv into dou squared by dou u dou v operated on x. So when you apply now, what is that? You just take this phi inside. So you will get it as u squared into dou squared phi by dou u dou v squared plus v squared into dou squared phi by dou u squared minus 2uv dou squared phi by dou u dou v. You call this particular result, what we have got for dou squared phi by dou x squared as number 1 and call this as number 2. Now what are you asked to find? You are asked to find what is the addition of these two. Addition of this and addition of this. That means add this and this. Add this with this. So what is that you will get? Dou squared phi by dou x squared plus dou squared phi by dou y squared is equal to, what is the value of this? See, I have got here, use 1, u squared dou squared phi by dou a squared dou u squared plus v squared into dou squared phi by dou v squared plus 2uv into dou squared phi by dou u dou v plus add this u squared dou squared phi by dou v squared plus v squared dou squared phi by dou u squared minus 2uv dou squared phi by dou u dou v. Now this is plus and minus, they will get cancelled, and this is dou squared u by dou u squared. See, here you have got dou squared u by dou u squared. Here you have got what? Dou squared phi by dou u squared. Add these two. U squared dou squared phi by dou u squared. V squared dou squared phi by dou u squared. When you add, it is u squared plus v squared into dou squared phi by dou u squared. Then add these two. Add these two. V squared dou squared phi by dou v squared plus u squared dou squared phi by dou v squared. So when you add these two, you will get it as u squared plus v squared into dou squared phi by dou v squared. You can find that these two are common. This is common. So take the common factor outside. So this is common. So when you pull that outside, you get u squared plus v squared. What is remaining inside? This remains. Dou squared phi by dou u squared and dou squared phi by dou v squared. So what is the result that you get? U squared plus v squared into dou squared phi by dou u squared plus dou squared phi by dou v squared. So we are able to get the result. The only thing that you must remember is this place you must know this place very well. How to do this, how to write this is very, very important. And writing the same way, this is very, very important. Once if you are able to write these two, you see that the rest of the things are easy for you. So this is an important question. As